Welcome to our channel. Today we explore one of the most powerful events in the universe, something so bright and so intense that it can outshine an entire galaxy. We are talking about supernova, the final moments of a star's life. But this story is not just about destruction, it is also about creation. In this video, you will learn how a peaceful star suddenly collapses, how the explosion forms new elements like gold and iron, how these elements travel across space, and how they become part of new worlds. You will discover how supernova-shaped galaxies create neutron stars and black holes, and even help reveal the age and size of our universe. Most surprising of all, you will learn how every human being carries the remains of old stars inside their body. There is so much mystery in this topic, and each chapter of the video opens another door to understanding the universe around us. If you enjoy this journey, please like this video, subscribe to our channel, and let's begin. The story of a supernova begins long before the explosion. It begins in the quiet life of a star that looks calm from the outside, but hides great power within. When we see a star in the night sky, it shines in a soft and steady way. It does not look angry. It does not look ready to burst. But inside the star, a slow and steady struggle is taking place every second of its life. The star is made of gas that wants to collapse under its own weight, and heat that pushes outward. These two forces keep the star alive. As long as the outward push and the inward pull stay balanced, the star stays stable. This balance is held together by nuclear fusion. Fusion is the simple process of small elements joining to become bigger ones. This process releases energy, and the energy moves outward. It travels through the layers of the star, reaches the surface, and escapes into space as light and heat. This is why the star shines. It is a natural lighthouse in the dark universe, glowing because of the energy it makes. Millions of years pass as the star continues this dance. Hydrogen becomes helium. Helium becomes heavier elements. Each step requires more heat and more pressure than the step before. Inside the star, new layers form, each burning a different element. The star grows older, but it keeps holding its shape. From far away, it still looks like a tiny bright dot, calm and patient. But nothing stays the same forever. There comes a time when the star starts to run low on fuel. The easy fuel goes first, and the star must begin to burn heavier elements. When the fuel changes, the star's body changes too. The outer layers swell and spread out. The star becomes much bigger than it was before. It becomes a red giant, glowing with a softer, deeper light. Even though it looks gentle, this change is a sign that the star is reaching its final phase. Inside the core, conditions become more extreme. The fusion reactions move faster. The temperatures rise. The pressure increases. The star continues to fuse heavier elements until it reaches iron. Iron is different from the other elements. When the star tries to fuse iron, something strange happens. Instead of making energy, iron takes energy. The star does not gain anything from this fusion. It is like pushing a heavy door that does not move. The star has reached a point where it can no longer make the energy it needs to hold itself up. Now gravity begins to win. The outward push becomes weak. The inward pull becomes strong. The core starts to shrink. At first, the collapse is slow, but as the core becomes denser, the collapse speeds up. It becomes faster than anything we can imagine. The atoms inside the core are squeezed so close together that they change form. Electrons are pushed into protons, creating neutrons. Heat rises to unimaginable levels. But all of this is happening quietly, deep inside the star. The outer layers have no idea what is happening below them. They still float in place, unaware that the foundation beneath them is falling apart. When the core collapses completely, it becomes so dense that it cannot shrink anymore. The collapse stops in an instant, and the core hardens. When this happens, the falling layers slam into the stiff core. This sudden stop creates a shockwave. The shockwave tries to move outward, but the pressure is so high that it slows down. For a moment, it seems like the shockwave might die out. It is a moment of silence before the greatest blast in the universe. Then something else happens. Deep inside the core, countless tiny particles, called neutrinos, escape all at once. These particles hardly interact with anything, but there are so many of them that they carry away huge amounts of energy. When they move through the collapsing layers, they give the shockwave a sudden boost. The shockwave grows stronger again. It starts to move outward with renewed force. The shockwave moves through the star like a rising storm. It tears through the layers, heats everything in its path, and pushes the gas outward faster and faster. When it reaches the outer surface of the star, it bursts into space. This moment is the true birth of the supernova. The star that once shined peacefully now releases more light in a few seconds than it did in its entire lifetime. If we could watch this event from a great distance, the star would appear to brighten suddenly. For a moment, it could outshine an entire galaxy. It would be as if a new sun had appeared in the sky. The explosion is not silent, but the sound cannot travel through space. Instead, the energy spreads in every direction, carrying the star's matter far out into space. The outer layers fly outward at huge speeds. These layers contain elements that were created inside the star during its long life. They also contain new elements made during the explosion itself. The extreme heat and pressure of the explosion allow the creation of elements that cannot form inside normal stars. Gold, silver, uranium, and many others are born in these final seconds. This means every piece of heavy metal on Earth was created in a star that exploded long before our planet was formed. The star's core faces a different fate. Because it has collapsed so tightly, it becomes something new. If the star was not extremely large, the core becomes a neutron star. A neutron star is small but incredibly dense. It may be only the size of a large city, but it weighs more than our sun. If the star was even larger, the core collapses into a black hole, a point in space where gravity is so strong that nothing can escape. The explosion marks the end of the star, but it also begins a new story that stretches across space and time. The material thrown out will travel far, and for thousands of years it will move through space, shaping new clouds and new systems. The energy will fade slowly, leaving behind the memory of the star that once was. This is where the first part of the story ends, with a star giving everything it has in one final powerful moment. In the next part, we follow what happens to the material that spreads through space, and how this single explosion can change the universe around it in ways that last for millions of years. When the supernova explosion begins to move outward, the star that once lived for millions of years is now releasing everything it has in a single moment. The bright flash is only the start. The real story continues as the layers of gas, dust, and newly formed elements fly into space. These layers move at incredible speeds, faster than anything we can imagine. Some parts travel so fast that they can cross the distance of Earth to the Sun in only a few hours. The force of the explosion pushes everything outward with a power that is hard to understand. Yet at the same time, it follows simple laws of nature that guide every step of the event. The explosion is not smooth. As the shockwave moves through the star, different layers break apart in different ways. Some layers are thick and heavy, others are lighter and softer. The shockwave interacts with each layer, heating it, tearing it apart, and mixing the elements together. This mixing is important because it spreads the new elements created during the explosion into the rest of the material. Without this mixing, many elements might stay trapped in the core. Instead, they are scattered across space, where they can become part of new stars, planets, and even life. Right after the explosion, the temperature in the center is beyond anything we can compare to. It is hotter than the core of any star we know today. It is a place where atoms break apart and form again. New atomic structures appear in only a few seconds. These new structures are the heavy elements of the universe. If you think about the gold in a ring, the silver in a coin, or the iodine used in medicine, all of it was made in a moment like this. These elements are the rarest gifts of dying stars. As the gas expands, it cools slowly. The energy spreads out across a wider area, and the intense heat decreases. But even after cooling, the gas is still extremely hot. It will remain so for a long time. The cloud of gas grows larger, forming a glowing sphere that keeps expanding. Over time, this sphere will take on new shapes as it interacts with the space around it. Meanwhile, the core of the star continues to settle into its new form. If the star was not huge, the core becomes a neutron star. A neutron star is one of the strangest objects in the universe. It is so dense that the atoms inside it no longer have their normal structure. The electrons and protons have been squeezed together into neutrons. This makes the neutron star very compact. It is small in size but incredibly heavy. It spins quickly because the star's rotation speeds up during the collapse. Some neutron stars spin many times each second. As they spin, they give off beams of radio waves and light. These beams move like the light from a lighthouse. When the beam points toward Earth, we see a flash. We call these objects pulsars. If the star was very large, the core goes beyond being a neutron star. It becomes a black hole. A black hole is a place where gravity is so strong that nothing can escape, not even light. The black hole does not have a solid surface. It is simply a region of space with extreme gravity. The outer layers of the star never touch the black hole directly. They fall past the point of no return and disappear. A black hole is silent, but the space around it may glow if gas falls in and heats up. While the core becomes something new, the material outside keeps traveling. The cloud expands in every direction. The space around the star becomes filled with glowing gas. This glowing cloud is called a supernova remnant. It holds the full history of the star. It carries the elements made during the star's long life and the elements made during its final seconds. The remnant does not move through empty space. It moves through the interstellar medium, which is the thin gas and dust that fills the space between stars. Even though this gas is very thin, the supernova shockwave pushes through it, heating it and squeezing it. The shockwave creates ripples and waves in the interstellar medium. Sometimes, these waves help the gas come together and form new clouds. These new clouds may someday form new stars. As the cloud expands, it begins to cool and fade. The bright gas becomes dimmer. The hot colors slowly become softer. The shape of the remnant changes over time. Small differences in the explosion and differences in how the gas meets the surroundings create beautiful patterns. Some remnants look like rings, others look like waves or tangled threads. Each remnant is shaped by the life of the star that came before it. After a few hundred years, the remnant becomes large enough that we can see it through powerful telescopes. The Crab Nebula is one example of a remnant we can still see today. It was formed by a supernova that people saw almost 1,000 years ago. The Crab Nebula shows delicate, colourful strands of gas that glow because a neutron star inside it releases energy. This energy moves through the gas and lights it up like a lantern in a dark room. Even after thousands of years, a supernova remnant continues to grow. It becomes part of the galaxy's flow of matter. The elements inside the remnant move slowly, and over time, they mix with other gas. These elements become part of new star-forming regions. They join hydrogen and helium to form clouds that are rich in heavier elements. When these clouds collapse into new stars and planets, the older elements become part of the new system. In this way, a supernova is not just an end. It is the start of a chain of events that continues across millions of years. The star that exploded may never be seen again, but the elements it left behind will remain. They will travel across the galaxy, settle into new forms, and become part of the next generation of stars. This cycle of creation and destruction is one of the most important processes in the universe. The universe uses supernova to spread elements, to heat gas, and to spark new stars. Without supernova, many of the elements needed for life would never reach the places where planets can form. Our own solar system was shaped by a supernova that exploded long before Earth existed. That explosion sent elements into space that later became part of the cloud that formed our sun and planets. So the story of a supernova does not end with the explosion. It continues in every direction, across space and time. The light fades, the gas spreads out, and the core changes into a neutron star or a black hole. But the materials the star sends into space begin new journeys. They join other clouds, merge with other elements, and wait for the time when they will become something new again. This is the quiet truth of the universe. Nothing stays still. Nothing is wasted. Everything changes, form again and again. A star that dies in a blast can become part of a world that will one day shine with life. And all of it begins with the moment the star loses its balance and becomes something greater than itself. As the supernova remnant expands outward, it begins to stretch and twist into shapes that look almost like art. The patterns are not random. They are guided by the way the explosion moved through the star, the pressure of the shockwave, the density of the surrounding gas, and even the magnetic fields in space. These forces shape the remnant into rings, loops, strands, and waves of glowing material. When we look at these remnants through telescopes, we see colors that come from different elements lit by energy. The gas does not glow on its own. It needs power from a nearby star, a neutron star, or some form of radiation to light up. When the energy passes through the gas, the elements shine in different colors. Oxygen may glow green, hydrogen may glow red, and sulfur may glow in deeper shades. These colors form beautiful pictures that float in space for thousands of years. Inside many of these remnants, something remarkable sits at the center, the remains of the star's core. If it became a neutron star, it continues to spin rapidly. As it spins, it releases strong beams of energy from its magnetic poles. These beams sweep across space in circles. If Earth happens to lie in the path of these beams, we see them as repeating flashes. These flashes are so steady that they act like cosmic clocks. Some neutron stars flash several hundred times a second. Their rhythm does not change for years. Because of this steady pattern, scientists can use pulsars to study extreme physics and measure things like the passage of time in space. The pulsar inside the Crab Nebula is one of the most famous examples. It spins many times each second, sending waves of energy into the surrounding gas. These waves light up the nebula and make it appear alive. The gas forms rings that seem to pulse outward. Filaments stretch in every direction. The center glows with powerful radiation. The Crab Nebula is not just a picture of a star that died, it is a record of energy still flowing from the event. Supernova remnants also help us learn about the universe. By studying the shapes, colors, and movements of the gas, scientists can understand how strong the explosion was, how fast the material is moving, and how the shockwave behaved. In some remnants, we can still see fragments of the original layers of the star. These fragments help us understand what the star was like before it exploded. Every remnant is a kind of time capsule that holds clues from millions of years ago. As the remnant grows, something else begins to happen. The shockwave continues moving outward, but it slows down as it pushes against the interstellar medium. This medium is thin, but it spreads across the galaxy. When the shockwave hits it, the pressure heats the gas. This heated gas can create new clouds of material. If enough gas gathers in one place, it begins to collapse under gravity. Over time, this collapse becomes the start of a new star. In this way, supernova help create the next generation of stars. This process does not happen quickly. It takes thousands or even millions of years for a cloud of gas to collect, cool, spin, and collapse into a new star. But without the push from the supernova, many clouds would stay spread out and never come together. The shockwave acts like a spark that starts the process. It gives the gas the strength it needs to start falling inward. The more material that gathers, the stronger the pull of gravity becomes. Finally, after a long time, a new star is born. These new stars are often different from the older ones that came before them. The gas that forms them now contains heavier elements. This means the new stars may have planets around them. When the heavy elements collect in disks around young stars, they slowly turn into solid particles. These particles stick together, forming rocks, then bigger rocks, and eventually planets. This is one reason planets like Earth could form. Without the heavy elements from past supernova, there would be no solid worlds, no oceans, no air, and no life as we know it. Supernova do not just create new stars, they also shape the structure of the galaxy. The explosion sends gas outward, in all directions. This gas moves through the spiral arms of the galaxy, adding energy and shaping the flow of matter. When multiple supernova occur near each other over long periods of time, they can create bubbles or cavities in space. These cavities become large, low-density regions that allow light, energy, and particles to travel more freely. In some galaxies, these supernova bubbles can grow so large that they rise above the galaxy's disk, creating powerful winds of gas that escape into intergalactic space. When scientists look at other galaxies, they can see signs of these supernova winds. Some galaxies show long streams of gas flowing away from them. These streams were pushed out by the force of many explosions over millions of years. The stars that explode may be long gone, but the effects of their blasts remain. Supernova also play a role in spreading cosmic rays. These rays are high-energy particles that move through the universe at almost the speed of light. Many cosmic rays come from the shock waves of supernova remnants. When the shock wave moves through space, it can speed up particles to extreme levels. These particles then travel across the galaxy, interacting with magnetic fields and gas. When cosmic rays reach Earth, they can affect the atmosphere and help create clouds. They also help scientists study the history of supernova activity in our region of the galaxy. Another important thing supernova give us is information about the distance to faraway galaxies. Some supernova, called type Ia supernova, have a special property. They always explode with nearly the same brightness. This makes them useful as standard candles. When we see one of these supernova in another galaxy, we can compare how bright it looks to how bright we know it truly is. From this, we can calculate how far away the galaxy is. By studying many of these supernova, scientists discovered something surprising. The universe is not only expanding, but it is expanding faster over time. This finding changed our understanding of the universe and gave rise to the idea of dark energy. Dark energy is a mysterious force that seems to push galaxies apart. We do not know what it is made of or why it exists, but we know it affects the growth of the universe. Without type Ia supernova, we might never have learned this. The study of exploding stars led us to one of the biggest discoveries in modern science. Even with all these details, the most powerful meaning of supernova comes from the idea of connection. The atoms inside our bodies were created in stars. The iron in our blood helps carry oxygen. That iron was once part of the core of a star that exploded billions of years ago. The calcium in our bones, the oxygen we breathe, the carbon that forms life, all of it was formed in stars. Some of it came from normal stars that lived peaceful lives, but many of the heaviest elements came from stars that ended in fire. When a star explodes, it sends its parts into the universe. Those parts mix with other clouds. They become part of new systems. Over time, one of those systems became our solar system. The dust that was once scattered in a supernova remnant came together to form Earth. So when we look at the night sky and see the faint glow of a distant star, we are seeing something that once helped create us. We are connected to the universe not only through space, but through the very atoms that build our bodies. This is the gift of a supernova. It reminds us that creation and destruction are part of the same story. A star must end for new life to begin somewhere else. The explosion may look violent, but it leads to growth that lasts for billions of years. The universe uses the death of stars to plant the seeds of new worlds. This cycle continues endlessly, shaping galaxies, forming planets, and building life from the ashes of stars. The supernova continues to spread across space, but the story does not end with the gas expanding and the remnant glowing. A supernova has another important role in the universe. It acts as a tool for understanding distance, time, and the structure of the cosmos. Not every supernova is the same. Some happen in massive stars that collapse, others happen in smaller stars that gain too much material. One particular type, called a Type Ia supernova, is especially useful. These explosions come from white dwarf stars in binary systems. A white dwarf is the leftover core of a smaller star like our Sun. It is very dense and stable, but only up to a point. When a white dwarf pulls too much material from a nearby companion star, it reaches a limit. The pressure becomes so high that the entire star explodes at once. What makes a Type Ia supernova special is that it always reaches almost the same brightness. Because of this, scientists can use these explosions as a measuring tool. When we know the true brightness of something, we can calculate how far away it is by measuring how dim it looks from Earth. This method has helped researchers measure distances to galaxies far away from the Milky Way. By looking at many Type Ia supernova, scientists learned how fast galaxies are moving. They could see how the universe has grown over time. When they compared the data, they noticed something very surprising. The universe was not expanding at a constant rate. It was expanding faster and faster. This growing speed was not expected. It suggested that there must be some unknown force pushing galaxies apart. This force is called dark energy. Dark energy makes up a large part of the universe, yet we cannot see it or touch it. We only know it exists because of the way distant supernovae behave. This discovery changed the way we think about the universe. It showed us that the cosmos is not slowing down, it is speeding up. Without supernova, we might never have known this. Stars that died billions of years ago helped us understand the future of the universe, while supernova help us understand the large-scale behavior of the cosmos. They also give us insight into nearby stars. In the Milky Way, supernova happen roughly every 50 to 100 years, but we do not always see them. Many explosions are hidden behind thick clouds of dust. These clouds block visible light. Even if a supernova shines as bright as a whole galaxy, we might not see it if dust lies in front of it. However, other forms of radiation can pass through dust. Infrared light, X-rays, and radio waves can help us find hidden explosions. Modern telescopes use these wavelengths to discover supernova remnants we never knew existed. One of the mysteries in our own galaxy is that we have not seen a bright, visible supernova in hundreds of years. The last one people saw clearly from Earth was in the year 1604, known as Kepler's supernova. Before that, there was one in 1572 and one in 1054, which created the Crab Nebula. Since 1604, there have been no bright supernova visible to the naked eye in our galaxy, even though we believe several must have happened. If one happened behind a thick cloud of dust, it would not appear as a star in the sky, but its remnants could appear later when we observe the region with modern instruments. Although we have not seen a recent one with our own eyes, astronomers expect that a bright supernova will occur in our lifetime or in the next few generations. It is not something to fear. If it happens far enough away, and most likely it will not harm Earth. Instead, it will give us an amazing chance to study the event closely, using all our modern tools. We might learn things that were impossible to discover before. There is one star people talk about often when discussing future supernova: Betelgeuse. Betelgeuse is a red giant star in the constellation Orion. It is one of the brightest stars in the night sky. For many years, scientists have known that Betelgeuse is nearing the end of its life. The star is large and unstable. It swells and shrinks as it burns through the last of its fuel. A few years ago, Betelgeuse dimmed in a dramatic way, causing excitement around the world. People wondered if it was preparing to explode. but the dimming turned out to be caused by dust clouds and natural changes in the star's outer layers. Betelgeuse will explode one day, but we do not know when. It could happen tomorrow, or it could happen in 100,000 years. When it does explode, it will be an incredible sight. It will shine as bright as the moon for weeks. But even though it will look close, Betelgeuse is too far away to harm Earth. The explosion will not affect our planet. It will simply give us a bright show in the sky, a rare front row look at the death of a massive star. Betelgeuse is not the only star that will explode in the future. There are many stars in our galaxy that will become supernova. Most of them are far away. They live in clusters where massive stars are born together. These clusters contain stars that live fast and die young. Massive stars burn through their fuel quickly. They do not last long before they collapse. Many of these stars will explode within the next few million years, but because they're far away, we might only see them through telescopes. When a new supernova appears, scientists from around the world will study it. They will look at its light, its energy, and the speed of its expansion. They will search for neutrinos and gravitational waves, which are other forms of signals that come from the explosion. Each new supernova brings new information, allowing us to understand the physics of collapsing stars more clearly. Supernova also give us a way to learn about the life cycles of galaxies. In galaxies with many young stars, supernova happen often. These explosions help shape the galaxy's flow of gas. They heat the gas, stir it, and push it outward. This movement creates patterns that influence where new stars form. In galaxies where star birth has slowed, supernova happen less often. But even one explosion can have long-lasting effects. Sometimes, a supernova can trigger star formation in regions that were quiet. Other times, it can stop star formation by heating the gas too much. When the gas is hot, it does not collapse easily. So one supernova can either start or pause the creation of new stars, depending on where it occurs. In this way, supernova help regulate the balance of a galaxy. They prevent gas from sitting still for too long. They make sure that the galaxy keeps changing, keeps growing, and keeps recycling material. Without supernova, galaxies would become cold and quiet. They would stop forming stars. The life cycle of matter would slow down. Supernova are also a reminder of how fragile and powerful the universe is. A star that looks peaceful can hide enough energy to change everything around it in a single moment. And yet, this change creates beauty, new stars, and new forms of life in the distant future. The explosion of a star can scatter seeds that travel across the galaxy. These seeds may rest for millions of years before joining a new cloud of gas. But once they do, they begin a new journey. When we study these explosions, we are not just learning about stars, we are learning about our own origins. The atoms in our bodies were once inside stars. Some of those stars exploded. Their remnants spread through space and became part of new systems. When you look at your hands, the iron in your blood was born in a massive star that ended long before our sun formed. This connection makes supernova more than scientific events. They are part of our history, written in the atoms we carry. The more we observe supernova, the more we understand the universe. Each explosion is a message from the past. It tells us how stars lived, how they died, and how they shaped the space around them. It tells us how galaxies grow, how elements spread, and how new structures form. It tells us that the universe is always moving, always changing, always creating. Supernova have shaped human history in ways we often forget. Long before telescopes, long before science, people looked at the sky and noticed when a new star suddenly appeared. They did not know it was a star dying. They did not know it was the final breath of a massive sun far away, but they felt its power. They wrote about it. They painted it. They wondered what it meant. These old records help us today understand which supernova were seen from Earth and how bright they were. One of the most famous events happened in the year 1054. People in China, Japan, and the Middle East recorded a new star that appeared suddenly in the sky. It was so bright that it could be seen during the day for weeks. At night, it outshined every other star. People called it a guest star. They did not know it was the explosion of a massive star thousands of light years away. That star left behind a remnant we still see today, the Crab Nebula. The Crab Nebula glows with colourful strands of gas shaped by a spinning neutron star at its centre. When astronomers study it, they see details that match the old writings from centuries ago. Another famous supernova was seen in 1572. It appeared in the night sky when people in Europe were beginning to question old beliefs about the heavens. A bright new star appeared where no star had been before. The astronomer Tycho Brahe studied it carefully and showed that it was far away, not something in Earth's atmosphere. His work helped prove that the universe was not perfect and unchanging, as many people believed. It showed that the sky could change, that stars could die, and that the cosmos was more dynamic than anyone thought at the time. In 1604, another bright supernova lit up the sky. This event, recorded by the astronomer Johannes Kepler, became known as Kepler's supernova. It stayed bright for many months. Today, the remnant of this explosion can be seen through telescopes as a growing cloud of gas shaped by the blast. The supernova of 1604 was the last one clearly seen with the naked eye in our galaxy. More than 400 years have passed since then, even though we know several supernovae must have happened behind dust clouds that blocked the light. The modern age brought new tools for observing supernova. The invention of the telescope allowed us to see faint objects, measure distances, and understand the structure of stars before and after they explode. But one of the biggest breakthroughs came in 1987 with the appearance of a supernova in a nearby galaxy called the Large Magellanic Cloud. This event is known as Supernova 1987A. It was close enough for scientists to study in great detail. For the first time, detectors on Earth recorded neutrinos from the explosion. These tiny particles arrived before the light, just as theory predicted. It was the first direct evidence supporting the idea that neutrinos play a major role in helping the star explode. The event confirmed many ideas scientists had about how supernova work internally. Supernova 1987A also allowed researchers to watch the remnant form in real time. They observed the shockwave moving outward. They saw how the gas began to glow. They watched as the cloud expanded and interacted with the material around it. Even today, decades later, scientists continue to study it. Every year, it reveals new details about the life cycle of an exploded star. But supernova are not only something we see in distant galaxies or read about in history. They also shape the formation of our own solar system. Before the Sun was born, the region of space where it formed contained dust and gas. This cloud was quiet until something powerful disturbed it. One likely explanation is that a nearby supernova sent shockwaves into the cloud, causing it to collapse. The explosion also sent freshly made elements into the cloud. When the cloud collapsed and formed the Sun and planets, the heavy elements from the supernova became part of the building blocks of our world. We see hints of this in meteorites. Some meteorites contain unusual elements that do not come from normal star processes. They appear to come from a recent supernova that happened shortly before our system formed. These elements were trapped inside rocks that later fell to Earth. They are clues that a dying star helped trigger the birth of our Sun. Our planet carries a story that began long before it existed. The iron in Earth's core came from stars. The heavy metals in the crust came from supernova. Even the carbon used in living cells was formed inside stars that lived and died billions of years ago. Everything around us carries this history. When scientists study supernova, they are studying the origins of planets, oceans, air, and life itself. In the night sky, the light from supernova remnants travels great distances before reaching us. When we look at them, we are looking into the past. A remnant might be thousands of years old, but its light takes time to travel. What we see now happened long before humans built cities, before languages formed, before history began. The universe shows us events that happened far away and long ago. Light from the Crab Nebula started its journey around the time when ancient civilizations were rising. Today, it reaches our telescopes, giving us a glimpse into a distant age. This sense of time makes supernova important not only for science, but also for our understanding of our place in the universe. They remind us that the cosmos is old, vast, and constantly moving. Stars are born, they live, and they die. Their explosions spread the elements needed for planets and life. Over millions of years, new stars form from the remains of old ones. The cycle continues without pause. Supernova also help us understand how galaxies change shape. A galaxy is not just a group of stars, it is a network of gas, dust, dark matter, and energy. When a star explodes, it sends gas into the galaxy. This gas joins the larger flow and becomes part of the galaxy's structure. Over time, the repeated explosions of many stars help move gas around and create patterns. In spiral galaxies, star formation often happens in the spiral arms. These regions glow with bright young stars. The deaths of the massive stars in these arms create supernova that spread heavy elements into the galaxy. Some galaxies have large bubbles or holes in their gas. These were carved out by many supernova over long periods. The explosions push gas outward, leaving empty regions behind. When we see these bubbles, we know that many stars must have exploded there in the past. Scientists also use supernova to learn about the elements in the universe. By studying the light from a supernova, they can identify which elements are present in the explosion. Every element leaves a unique signature in the light. These signatures appear as lines when the light is spread out into a spectrum. By looking at the spectrum of a supernova, researchers can see which elements were inside the star. They can also see how fast the gas is moving. If the lines shift, it means the gas is speeding toward us or away from us. These measurements help us understand the life stages of stars. If a supernova shows hydrogen in its light, the star likely still had its outer layers at the time of the explosion. If hydrogen is missing, the star may have lost its outer layers through strong winds or through interaction with a companion star. Each supernova type tells a different story about the star that came before it. Some supernova come from stars that lose almost all their material before exploding. Others come from stars that have swollen into great red giants. Some come from binary stars that steal material from one another. In this way, supernova show us the diversity of star lives. They reveal that the end of a star can take many forms. Although supernova are destructive, they create the conditions needed for life to appear. They spread elements through space. They trigger new star formation. They heat and mix gas. They help build the next generation of worlds. The explosion of a single star can shape a region of space for millions of years. When we stand on Earth and look at the night sky, it is easy to forget that everything we see and everything we are made of once came from stars. But supernova remind us of this truth. They are the heartbeat of the galaxy, keeping it alive by sending out new material. They show us that endings can lead to beginnings, and destruction can lead to creation. The universe is full of these explosions. Some happened before the sun formed. Some are happening now in distant galaxies. Some will happen in the future in stars we see in the sky. Each one marks a turning point in the life of a star. Each one adds new elements to the universe. Each one shapes the path of the galaxies through which it spreads. In our galaxy today, many stars continue to live out their long lives, burning quietly and shining in steady patterns. But scattered across the Milky Way are stars that are close to their final moments. These stars are massive, unstable, and aging quickly. They live shorter lives than small stars like our Sun. Because they burn their fuel so fast, they reach the point of collapse in a few million years, which is very short on cosmic scales. These stars remind us that the Milky Way is not just a calm, peaceful place. It is filled with cycles of birth and death happening all the time. One of the stars that has captured the most attention is Betelgeuse. This star sits in the constellation Orion, one of the most recognizable patterns in the night sky. Betelgeuse is large, bright, and red in color. It shines with a warm glow that makes it easy to spot. For thousands of years, people have looked at Orion and noticed Betelgeuse in the upper left corner of the pattern. It is a star that has always stood out. Betelgeuse is in the late stages of its life. It has burned through most of its hydrogen fuel and has expanded into a red supergiant. If Betelgeuse were placed in the center of our solar system, it would extend far beyond the orbit of Mars. Its outer layers are thin compared to its size, and they change shape as the star releases energy. The surface of Betelgeuse is not smooth. It has giant cells of rising gas, each larger than our entire planet. These rising and falling layers give the star a restless appearance. For many years, astronomers have known that Betelgeuse will one day explode as a supernova. It has all the signs of a star nearing the end. But we do not know exactly when it will explode. It could be very soon, or it could be far in the future. The uncertainty makes the star fascinating. People often ask if Betelgeuse will explode in our lifetime. The answer is simple. It might, but there is no way to know for sure. A few years ago, something unusual happened. Betelgeuse began to dim. Its brightness dropped much more than normal. This sudden change caused excitement around the world. Some people thought it was a sign that the star was about to explode. But when astronomers looked more closely, they found another explanation. A large cloud of dust formed near the star and blocked some of its light. At the same time, one of the giant gas cells on the star's surface cooled, making the star dimmer. These two events happened at the same time and made Betelgeuse look much fainter than usual. After a few months, Betelgeuse began to brighten again. It returned to its normal state. Scientists now believe the dimming was not a signal of an upcoming explosion, but a natural event that happens when a star like Betelgeuse behaves unpredictably. Still, the dimming reminded everyone that Betelgeuse is a star nearing the end of its life. It is fragile in a cosmic sense. It is changing slowly as it burns through the last of its fuel. If Betelgeuse does explode as a supernova, it will be an amazing sight from Earth. The explosion will shine brighter than the full moon. It will be visible during the day for weeks. People all over the world will look at the sky and see the bright point of light. But even though it will look close, Betelgeuse is far enough away that the explosion will not harm Earth. The radiation will weaken by the time it reaches us. The only effect will be the bright light and the chance to study the event closely. Astronomers would use every tool available to observe the supernova. They would measure its light. They would look for neutrinos and gravitational waves. They would study the expanding gas. The explosion would give scientists a rare chance to watch a supernova unfold in real time. We have never seen a supernova this close with modern technology. It would help confirm theories and reveal new details we did not know before. But Betelgeuse is not the only star that will one day explode. Across the Milky Way, massive stars are reaching the ends of their lives. Many of these stars sit in clusters where they were born. A star cluster is a group of stars that formed from the same cloud of gas. The massive stars in these clusters burn quickly and die young. They become supernova within a few million years. Because these clusters contain many massive stars, supernova happen there often. When one star explodes, it spreads heavy elements into the cluster, enriching the gas. When another star explodes, the process continues. Over time, the region becomes filled with the elements needed to form planets and other structures. Although we cannot see every supernova that happens in our galaxy, scientists can detect their remnants. These remnants may appear as glowing shells, rings, or waves of gas. They stretch across the sky and show the shape of past explosions. Some remnants have a pulsar at their center. Others have black holes that are invisible except for their effect on nearby material. By studying these remnants, astronomers can estimate how many supernova happened in the past. They can also learn how often massive stars reach the end of their lives. Supernova also affect the space between stars. The shock waves from the explosions push gas outward. This gas carries new elements and heats other clouds. When the shock wave slows down, it can leave behind regions of high pressure. These regions can compress clouds and help form new stars. In this way, supernova help shape the structure of the galaxy. They push and pull gas into patterns that influence where new stars appear. Some regions of the Milky Way have huge bubbles carved out by supernova. These bubbles are areas of low density surrounded by walls of gas. They may contain old remnants, pulsars, and hot gas created by explosions. The local bubble, the region of space our Sun is currently in, is thought to have been shaped by several supernova that exploded millions of years ago. The Sun moved into this bubble long after the explosions, but the bubble still exists as a reminder of the events that shaped our neighborhood in the galaxy. Even though supernova can be dramatic and powerful, they are also a normal part of the universe. They have been happening since the earliest times. The first stars in the universe were massive and burned their fuel quickly. Many of them ended as supernova. These early explosions helped spread the first heavy elements into space. Those elements became the building blocks for later stars, planets, and galaxies. Without these early supernova, the universe would be very different. It would contain only hydrogen and helium, the simplest elements. There would be no carbon, no oxygen, no nitrogen, and no metals. Stars would still form, but planets like Earth might not exist. Life as we know it might not appear. So supernova were essential in shaping the universe we see today. In the same way, future supernova will help shape the universe that comes after us. They will add new elements to the galaxy. They will help create new stars and planets. They will leave behind neutron stars and black holes that will continue to influence their surroundings. The galaxy is always changing, and supernova are one of the main forces driving that change. When we look at a star that will explode someday, we are looking at the future of space. When we study the remnants of past supernova, we are looking at the past. The universe gives us both at the same time. It shows us where things came from and where they are going. It shows us the beginning and the end side by side. Supernova are powerful reminders that even the brightest stars do not last forever. But they also remind us that endings are not empty. They create new paths, new materials, and new possibilities. A supernova may be the end of a star, but it is never the end of the story. It is the start of something new that will unfold across millions of years. As supernova continue to shape the galaxy, people naturally wonder whether these powerful explosions can harm life on Earth. The idea of a star exploding is frightening when you imagine the amount of energy released. The blast is strong enough to tear a star apart, throw gas across space, and light up a whole galaxy. But even though a supernova is powerful, it is also very far away. Space is huge, and stars are spread out over great distances. Because of this, most supernova are too far from Earth to cause any danger. The amount of energy that reaches Earth from a supernova depends mainly on how close the star is. If the star is thousands of light years away, the energy spreads out so much that only a tiny fraction reaches our planet. We might see a bright light in the sky, but the energy does not affect life. If a supernova is a few hundred light years away, we may notice some changes in our atmosphere, but these changes would still be small. Scientists believe that only a supernova within about 30 light years could cause serious harm to Earth. This distance is quite small compared to the size of the galaxy. Fortunately, there are no stars within this distance that are likely to explode. Betelgeuse, for example, is much too far away to hurt us. Many massive stars are far from our solar system. They live in regions full of young stars, often far from where our Sun is located. Even if one of them exploded, the energy would be spread so widely that Earth would not feel the force. There is a special case to consider, a type of explosion called a gamma-ray burst. Some supernova produce narrow beams of intense radiation that shoot out from the poles of the star. These beams are called gamma-ray bursts. When they occur, they release more energy in a few seconds than the Sun will produce in its entire lifetime. Gamma-ray bursts are extremely powerful, but they point in very specific directions. If the beam does not point toward Earth, we would never notice it, and most gamma-ray bursts come from stars in other galaxies far beyond our own. Even if a gamma-ray burst happened in the Milky Way, it would have to be aligned exactly with our solar system to affect us. The chances of this happening are extremely small. Scientists believe that gamma-ray bursts are rare and occur mostly in young galaxies with many massive stars. Our galaxy is older and calmer, so the chances of a dangerous burst are even lower. It is not something we need to fear. Even though supernova pose little danger to Earth, they still have important effects on the galaxy as a whole. They help recycle matter. They send shockwaves into clouds. They move gas around. They help build the next generation of stars. These processes are essential for maintaining the galaxy's long-term health. Without supernova, the Milky Way would look very different. It might be quieter, but it would not grow in the same way. When scientists study the energy from supernova, they also learn about the safety of our planet. They look at the radiation that comes from these explosions and measure how much of it reaches us. They use computer models to see how different types of supernova would affect Earth at different distances. These studies help confirm that Earth is safe from most nearby explosions. Even the Sun will not become a supernova. Our Sun is not massive enough. It will end its life gently compared to massive stars. It will expand into a red giant in billions of years, then shed its outer layers and leave behind a white dwarf. It will not explode. It will not create shock waves or heavy elements. It will simply cool over time. When people think about the power of a supernova, they often imagine something violent and destructive. But in truth, the explosion is only one moment in a much longer story. It is not meant to destroy everything around it. It is a natural part of the universe, a way of returning material to space so it can be used again. The energy from the explosion eventually fades, and the gas spreads out and becomes part of the galaxy. In this calm way, the universe recycles itself. It breaks apart old structures and builds new ones. Nothing is wasted. Even the most powerful events lead to new beginnings. The cycle continues, shaping the galaxy for billions of years. Supernova also help us understand the limits of life in the universe. If a planet orbits too close to a massive star, it may not survive the explosion. But if a planet orbits far enough away, it remains safe. This helps scientists think about which parts of galaxies may support life. Regions with many massive stars may not be the best places for life to grow because supernova happen often there. Areas like the outskirts of galaxies or in calm zones between spiral arms may be safer. In our own galaxy, the Sun sits in a position that is safe from most dangers. We live in a quiet part of the Milky Way, far from the crowded star-forming regions. This location likely helped life on Earth evolve without too many interruptions. If we were closer to more massive stars, the story of life might have unfolded differently. Even though supernova can be dangerous close-up, they create the materials needed for life. They make oxygen, carbon, iron, and many other elements. These elements become part of planets, air, water, and living organisms. Without supernova, there would be no Earth, no oceans, no rocks, and no humans. So even though they can destroy nearby planets, they make life possible in the long run. When we think about life in the universe, supernova are a reminder that creation can come from destruction. A star must die in order for new materials to be created. It is a cycle that repeats across the cosmos. Life grows from the remains of stars. This idea is simple but powerful. It connects every living thing to the universe in a deep way. Scientists also study supernova to understand how radiation travels through space. The radiation from an explosion moves outward like waves. These waves spread and weaken as they travel. They can heat gas, ionize atoms, and change the behavior of molecules. But they cannot travel forever. Eventually, the energy fades. The space between stars is so large that most radiation never reaches another star in a harmful way. Even planets around the exploding star can sometimes survive if they are far enough away. Scientists believe that some planets orbiting massive stars might escape complete destruction. The outer planets could lose their atmospheres, but stay in orbit around the remaining neutron star or black hole. Over time, the system could become stable again. These planets, if they still exist, would orbit a strange object, but they would continue their journey through the galaxy. Our own solar system might have neighbours that experience supernova in the distant future. But even if that happens, the distances between stars protect us. The galaxy is not crowded. Stars are far apart compared to their size. This gives planets room to exist without being constantly endangered by their neighbours. People sometimes imagine a sky full of exploding stars, but that is not the case. Supernova happen only occasionally. Most stars live long, stable lives. They shine quietly and gently. Only the most massive stars end in explosions. And even those explosions happen far away. In a way, supernova remind us of the calmness of space. They show us that change happens slowly. A star may take millions of years to reach its final moment. The explosion is only a heartbeat at the end of a long life. We see the bright flash, but we do not see the millions of years of peaceful burning that came before it. When the explosion happens, it sends a message across space. The light begins a journey that may last thousands of years before reaching another world. When we see that light, we are seeing something that happened long ago. The star may already have become a neutron star or black hole. The remnant may already be expanding, but the light continues to travel. It gives us a picture of the past. In this way, supernova connect different times. They link the moment of the explosion with the moment we observe it. They show us the history of the galaxy and the history of the universe. When we think about a supernova, it is easy to focus on the explosion itself. The light is bright, the energy is extreme, and the blast is powerful enough to tear a star apart. But one of the most important parts of the story is what the explosion leaves behind. The gas and dust that spread into space carry the elements that will someday become part of new systems. And many of these elements are necessary for life. This is why people often say that we are made of stardust. It is not a poetic idea. It is a simple scientific fact. The iron in our blood, for example, was made in a star that exploded long before Earth formed. Iron is created when a massive star builds heavy elements deep inside its core and then sends them into space during the explosion. The iron travelled through space for millions of years before becoming part of the cloud that formed the sun and planets. Today, that same iron helps carry oxygen in our bodies. Carbon, another important element for life, was formed inside stars long ago. Oxygen was also made inside stars. These elements became part of the gas clouds that collapsed to form new stars and planets. Without supernova spreading these elements everywhere, life as we know it could not exist. Everything from the bones in our bodies to the breath in our lungs has a story that begins inside a star. Silver, gold, platinum, and many other rare elements also come from supernova. These elements are created during the most intense moments of the explosion, when the temperature and pressure are extremely high. They are formed in just seconds, but they last forever. They become part of planets, rocks, and even tools and jewelry that humans make. Every time we see a piece of gold, we are looking at something that was created in the last breath of a dying star. These elements are scattered far and wide by the explosion. They mix with other gas and dust, forming new clouds in space. Over time, gravity pulls these clouds together. They collapse to form new stars, and around these stars, disks of material form. These disks slowly become planets. In this way, the material from old stars becomes the building blocks for new worlds. The cycle of creation in the universe is slow but steady. A star dies, sends its elements into space, and eventually helps create new stars and planets. These planets might become places where life forms. Even the water on Earth has a connection to these ancient processes. The oxygen in water came from stars. The hydrogen in water came from the very beginning of the universe. When the two combined on Earth, they created oceans, rivers, and the water we drink. All of it is connected to the history of stars. When we study supernova, we are not just learning about explosions, we are learning about the origin of life. The elements needed to build living organisms did not appear by chance. They were created in stars. These stars lived long lives, used their energy to build heavier elements, and then spread those elements into the universe. Without supernova, Earth would not exist in its current form. In many ways, supernova are our ancestors. They lived and died long before humans appeared. They shaped the materials that became our world. They prepared the conditions needed for life to grow. Every living thing on Earth carries the memory of those stars. The atoms inside us were once part of a star that exploded billions of years ago. This idea connects us to the cosmos in a deep and meaningful way. Supernova teach us that creation and destruction are connected. A star must destroy itself in order to release the elements that will form new planets and new forms of life. It is a process that takes millions of years, but it is one of the strongest forces guiding the growth of the universe. Without supernova, the galaxy would not have the diversity of elements needed to build complex structures. These explosions also help balance the galaxy. They stir gas, shape clouds, and add heat to areas that would otherwise stay cold and still. This movement helps keep the galaxy active. It prevents gas from settling in one place for too long. It encourages new star formation. It spreads elements evenly across different regions. All of these effects help the galaxy grow and evolve over time. Scientists study supernova not only to understand how stars die, but also to learn about the early universe. Some of the first stars that ever formed were much larger than stars we see today. These early stars burned quickly and ended their lives in powerful explosions. Their supernova created the first heavy elements in the universe. These elements then became part of the next generation of stars. By studying the remnants left behind by old explosions, scientists can learn about the early conditions of the universe. Even though supernova happened far away and long ago, we can still see their light today. The light from an explosion travels through space for thousands or millions of years before reaching Earth. When we observe a supernova in a distant galaxy, we are seeing something that happened long before humans existed. The star may already be gone, but its light is only now arriving. This makes the night sky like a time machine. It shows us events from the past, frozen in light. When we look at supernova in many different galaxies, we can learn how the universe has changed over time. We can see how star formation has grown or slowed. We can see how galaxies have evolved. We can study how often different types of supernova happen. All of this information helps scientists build a picture of how the universe has expanded and changed since the beginning. Supernova also help us understand the conditions needed for life elsewhere in the universe. If life depends on elements like carbon, oxygen, and iron, then planets around young stars may not have enough heavy elements to support life. These planets may be made mostly of hydrogen and helium. It takes several generations of stars exploding before the galaxy becomes rich enough in heavy elements to form Earth-like planets. This means that life, at least life as we know it, is more likely to appear in older galaxies or in older regions of galaxies. This idea changes the way scientists search for life. They look for planets around stars that formed after enough supernova had spread heavy elements into the region. These planets may have the right conditions for life. They may have water, air, and solid ground. Without supernova, none of these things would exist. When we understand the role of supernova, we understand our own story better. We see that we are part of a long chain of events. A star exploded billions of years ago. The elements traveled through space. They became part of the cloud that formed our sun. The planets formed. Earth cooled. Life began. Over time, life evolved into many forms, including humans. All of this came from the materials created in stars. Supernova show us that we are not separate from the universe. We are part of it. Everything on Earth has a cosmic origin. When we breathe, walk, eat, or think, we use elements that were once inside stars. The universe built the conditions that allow us to live. We carry the history of stars in our bodies. This connection gives supernova a meaning beyond science. They remind us that we belong to the universe and the universe belongs to us. Every star that explodes helps shape the future. Every atom that moves through space is part of something larger. Supernova are the universe's way of renewing itself, creating new possibilities and building new worlds. For billions of years, stars have been dying and exploding, sending their elements across the galaxy. New stars form, planets take shape, and life appears from the remains of old worlds. This cycle will continue long after we are gone. The universe will keep changing, and supernova will keep guiding that change. When we look at a supernova through a telescope, we are not just seeing a bright object in the sky. We are seeing a message from the past. The light from a supernova travels at the speed of light, but even at that speed, it takes time to cross the vast distances of space. A supernova that happened thousands of years ago may only now be reaching Earth. A supernova in another galaxy may have exploded millions of years before humans ever existed. Yet we see it today as though it just happened. This idea can feel strange at first. When we look at stars, we see them not as they are now, but as they were when their light began its journey. The universe is so large that light takes time to travel from one place to another. Because of this, the night sky is filled with history. Every dot of light is a reminder of the passage of time. Every supernova we observe is a window into a moment long gone. This time delay helps scientists understand many things about the universe. When they observe a supernova in a distant galaxy, they can compare it to supernova in nearby galaxies. The differences tell them how galaxies have changed over time. They can see patterns of star formation. They can see how galaxies grow, how they interact with one another, and how they move through space. Supernova also helps scientists measure the expansion of the universe. As the universe expands, light from distant galaxies becomes stretched. This stretching changes the color of the light, making it appear redder. This effect is known as redshift. By measuring the redshift of light from supernova, scientists can calculate how fast the universe is expanding. Over time, they notice that the expansion is speeding up. This behavior led to the discovery of dark energy, the mysterious force pushing galaxies apart. Dark energy makes up a large part of the universe, yet we know very little about it. We cannot see it, we cannot touch it, but supernova helped reveal its presence. Without these explosions, we might never have understood the true shape and future of the cosmos. Supernova also helps scientists study the flow of matter around galaxies. When gas moves through space, it leaves signatures that can be detected through light. By watching how gas changes over time in supernova remnants, scientists can understand how gas behaves under extreme conditions. This helps us learn about many other things, including the formation of black holes, the behavior of neutron stars, and the structure of galaxies. Some supernova remnants show rings or shells that expand over time. By measuring how fast these rings grow, scientists can estimate the age of the explosion. They can also use these measurements to learn about the density of the surrounding gas. If the rings slow down, it means the shockwave is passing through denser material. If the rings speed up or stay large, it means the area around the explosion is less dense. Every remnant tells a different story. Some show signs of a peaceful expansion. Others show signs of collisions with nearby clouds. Some remnants have bright knots of gas that move at different speeds. These knots are pieces of the star that were thrown out during the explosion. Their movement shows the power of the blast and the direction in which the material travelled. In some cases, supernova remnants contain a neutron star at the centre. This neutron star may be spinning rapidly, sending beams of radiation into space. These beams create patterns that scientists can detect. When they observe these beams, they learn how fast the neutron star is rotating. They can also study how the rotation slows down over time. This slowing reveals the amount of energy the neutron star is losing. In other cases, the explosion leaves behind a black hole. Black holes are invisible, but their gravity affects the space around them. If gas falls toward a black hole, it heats up and gives off X-rays. By observing these X-rays, scientists can learn about the mass of the black hole and how it formed. Some black holes were once the cause of massive stars that exploded millions of years ago. Supernova also helps scientists study gravitational waves. These waves are ripples in space created by extreme events. When two neutron stars collide, they release strong gravitational waves. When these waves reach Earth, special detectors can measure them. Many neutron stars that collide were once formed in supernova explosions. So the study of supernova is linked to the study of gravitational waves, another powerful tool for understanding the universe. Even though supernova teach us so much, they also raise many questions. Why do some stars explode and others collapse quietly? Why do some explosions create black holes while others create neutron stars? What happens inside the star during the first few seconds of collapse? Scientists are still working to answer these questions. Each new supernova brings more clues. One of the things that makes supernova hard to study is that we cannot predict exactly when they will happen. We know which stars will explode someday, but we do not know the exact moment. A star may explode tomorrow, or it may explode in 100,000 years. We only know the general stage of its life. Because of this, astronomers constantly watch the sky for signs of new explosions. Modern technology makes this much easier. Telescopes on Earth and in space scan the sky every night. They compare images to earlier ones, looking for new points of light. When they see a new light appear, they investigate it immediately. If it is a supernova, they alert scientists around the world. In this way, we can observe supernova only minutes or hours after they appear. Every new supernova gives researchers a chance to learn something new. They measure its brightness, they study its spectrum to see which elements are present. They track how the brightness changes over time. This helps them identify the type of explosion and estimate the mass of the star that exploded. They also use supernova to study galaxies where star formation is happening. The more we study these events, the more we understand the universe. We learn about the nature of stars, the shape of galaxies, and the growth of cosmic structures. We learn about the behavior of matter under extreme conditions. We learn about the physics of gravity, pressure, and temperature. We learn how stars create the elements that form everything around us. Supernova show us that the universe is full of energy and movement. Even in the darkest corners of space, change is happening. Stars are being born, shining for millions of years and dying in powerful explosions. Their remains flow into the galaxy, joining new clouds of gas. From these clouds, new stars form. The cycle repeats endlessly. When we look at supernova remnants, we see this cycle written across the sky. The glowing clouds show where a star lived and died. The patterns in the gas show the path of the explosion. The colors show the elements released into space. These remnants are like stories written in light. In a way, supernova help us understand our own life cycle. They remind us that everything changes over time. They remind us that endings lead to beginnings. They remind us that we are part of something much larger than ourselves. When we look at a supernova, we are looking at a moment that shaped the future. A single explosion can change a region of space for millions of years. It can create new stars. It can form new planets. It can shape the galaxy. And one of those planets may one day hold life. This idea makes supernova more than scientific events. They become symbols of renewal and transformation. They show us that destruction is not always the end. It can be the start of something greater, something that grows from the remains of the past. When we reach the final part of the story of a supernova, we begin to see the larger meaning behind these great explosions. A supernova is not only the end of a star, it is not only a moment of brilliant light or a burst of energy. It is something much deeper. It is one of the ways the universe grows. It is how the galaxy stays alive. It is how new forms of matter appear, and it is how life, planets, and worlds become possible. A supernova is a single event, but its effects stretch across time far longer than the life of the star that created it. Imagine a star that lived for millions of years. It shined quietly, burning its fuel and holding itself steady. It looked calm from a distance, even peaceful, but inside it changed slowly until it could not stay stable anymore. Then in a single moment, it collapsed and exploded. The light travelled for thousands of years before reaching another world. The gas and dust travelled even longer, spreading out through the galaxy. Pieces of that star may have wandered through space for millions of years, drifting until they joined other clouds. One day, a new cloud may have formed a new star, a new set of planets, and perhaps a new form of life. In this way, the death of the star shaped a future it could never see. When we look at our own world, we see signs of these ancient events everywhere. The rocks in the mountains carry elements made in stars. The air we breathe holds atoms created in stars. The water in the oceans contains elements released by stars. Even the smallest cell in a living thing depends on elements made in dying stars. This is why many scientists say, we are children of the stars. We live because stars lived and died. We breathe because stars long ago released the oxygen that later became part of our planet. Supernova also remind us of the passage of time. The universe is very old. It has existed for more than 13 billion years. During that time, trillions of stars have lived and died. Each one played a role in shaping the universe we see today. The stars we see tonight are only a small part of the story. Many stars that once existed are gone now. Their remains spread through space. New stars have formed from the materials they left behind. The cycle continues, slowly but surely. When we look at a supernova remnant, we see only one moment in this long cycle. The glowing gas, the expanding shell, the spinning neutron star. These are just stages in a long process that began millions of years ago and will continue for millions more. The remnant will keep growing until it becomes faint and thin. Eventually, it will mix with the interstellar medium, becoming part of other clouds. The elements inside it will join new systems. They will take new forms. They will move on. This slow movement of matter is one of the universe's greatest stories. It is not fast or explosive in most moments. It is gentle, like dust drifting through the air. But over long periods of time, it changes everything. It builds galaxies. It forms clusters. It spreads the seeds of life. It creates the conditions for stars and planets to appear. Without this cycle, the universe would be empty and still. There would be no worlds, no life, no change. Supernova also show us the power of gravity and light. Gravity brings the star to collapse. Light brings the star to life. And at the end, energy is released so quickly that the light spreads across space like a message. When we observe this light, we learn about physics, chemistry, and the nature of matter. We learn about the structure of atoms, the limits of pressure, and the behavior of particles. We learn how the universe follows rules that hold true everywhere, from the smallest atom to the largest galaxy. In this way, supernova are teachers. They reveal truths about the universe that we could not learn otherwise. When scientists study the light from a supernova, they can see which elements were inside the star. When they measure the brightness, they can calculate how far away the explosion happened. When they track the gas, they learn how shock waves behave. And when they observe neutron stars or black holes, they learn about gravity at its strongest. These lessons help us understand the universe as a whole. Supernova also help us think about the future. The universe is still expanding and stars are still forming. New supernova will happen in the future. They will send new elements into space, shaping the next generation of stars and planets. Perhaps one of these future stars will have planets like Earth. Perhaps life will form on those planets. Perhaps intelligent beings will look at their sky and wonder about explosions happening far away. Even our own sun is part of this future. It will not explode as a supernova, but it will change. Billions of years from now, the sun will expand into a red giant. It will lose its outer layers, and its core will become a white dwarf. The material from the outer layers will drift into space, joining the interstellar medium. That material will not become heavy elements like iron or gold, because the sun cannot create them. But it will still add to the flow of matter in the galaxy. It will still be part of the cycle. And someday, that material may join a cloud that forms new stars. When we look at a supernova in the night sky, we are watching this cycle in action. We are seeing one moment in a long story that started long ago and will continue long after we are gone. The explosion is like a spark that lights the next stage of the universe's growth. It is a reminder that even the brightest moments fade, but their effects last forever. Supernova also help us think about our own lives. We often focus on moments of change or dramatic events, but most of life happens slowly, quietly, and over time. Just like stars, we have periods of growth, periods of change, and moments when everything shifts suddenly. But even difficult moments can lead to new beginnings. The universe shows us that endings can create new possibilities. A star's final explosion may look violent, but it creates the elements that will form new worlds. In the same way, changes in our own lives may open paths we could not see before. When we imagine the universe millions of years from now, we can picture countless stars living, shining, and dying. We can picture supernova lighting up galaxies. We can picture new planets forming around young stars. We can picture life appearing in places we cannot see. The universe may look very different in the future, but the cycle of stars will continue. Supernova will remain one of the universe's main engines of creation. The story of a supernova, then, is the story of the cosmos itself. It is a story of creation and destruction, of energy and matter, of beginnings and ends. It is a story of how small things come together to form larger things, and how those larger things one day return to their smallest parts. It is a story that never stops. When we look at the sky and see the faint light of distant stars, we see the evidence of this story all around us. We see the remains of stars that lived long ago. We see the birthplaces of stars yet to come. We see the tracks of explosions that shaped the galaxy. We see the quiet glow of gas that once was part of a brilliant sun. A supernova reminds us that the universe is always moving and always changing. It reminds us that every moment contains the possibility of something new. It reminds us that we are connected to everything around us, not only in space, but in time. The atoms inside us were once part of stars. They traveled through the galaxy for millions of years before becoming part of our bodies. This connection ties us to the universe in a deep way. And so, the story of a supernova ends with the understanding that nothing in the universe is ever truly lost. The star that explodes disappears, but its material remains. Its light fades, but its effects last forever. The universe carries the memory of the star in every piece of matter it left behind. And in time, that matter helps create something new. The journey of a supernova shows us how the universe grows, changes, and creates new possibilities from the end of a single star. It reminds us that nothing in space is wasted. Every atom moves on to become part of something new. The stars that lived and died long before us helped build the world we stand on today. And somewhere, far across the galaxy, the next star is already heading toward its final moment, ready to shape the future in ways we cannot see yet. Thank you for spending this time exploring the life and death of stars. If you enjoyed this story and want to learn more about the wonders of the universe, please like this video, subscribe to our channel, and we'll meet again in the next journey.